Welcome, ladies and gentlemen, to the Technical Forum of Hydrogen and Fuel Cells Europe at the Hannover Fair 2022. We have a whole bunch of very interesting presentations about the newest technology. And as I said before, filtration is a big issue, a big subject. Also, one's personal filtration, how much details can you take? What is essential? You need some system to control and to let the information come to you or not. And we have the specialist for filtration. The company's name is Hengst. And we get the product manager for fuel cell filtration of Hengst. Welcome with me with an applause, Mathias Diekjakobs.
Thank you very much. No, I don't need. Okay. Yes, thank you very much for the kind introduction. So today is the last day, and I also was 3 days on the fair trade on the exhibition. We are over there at C78. And I thought, okay, what to show on the last day, because somehow it felt like overdrained now. And yeah, I thought to bring maybe some interesting facts about filtration in general, because the questions are always the same, and often customers ask us, what's the matter with filtration? First of all, I want to introduce our company, which is located here in Münster in Westfalen, and it's about 250 kilometers away from here in the Western. We have over 3,000 employees. We are founded about 65 years ago, and have a turnover of nearly 600 million euro. And what's special at our company is we don't just send parts to our customer. We try to understand our customer and try to develop in common with our customers. So that somehow makes us special. Yes. Our portfolio, we do filtration over and out for all kind of medias. We have complex modules for filtration, highly integrated systems, but also filtration for vacuum cleaner. May you have a Hengst filter at home? It can be. But today, the focus is really on the fuel cell. And you can visit our exhibition down at the corner, and we have different filters in our exhibition. So I would be glad to talk to you about that. And the main thing is always about separation, water separation, ion exchanger. We release an ion exchanger cathode filter set here on this fair trade. But today I want to focus on cathode filtration because it's very interesting. We have to cover a lot of things with the cathode filter, and this I want to go into detail, but without telling too much details. I want to explain the wide range of filtration, what's the matter with it, and I want to tell you what has filtration to do with coconuts and football pitches. And in the end, I have to go back to our products, unfortunately, since we believe that our products have a good chance to meet your requirements. So, what is filtration? We have different particular manners coming from larger 1 millimeters to 0.1 nanometers. And here we got water drops, sand dust, sea salt is the manner, soot is the manner from exhaust, viruses is unfortunately a manner. Since years we're working on that, and also gases. Gases are nothing else than molecules, particles in very, very small, tiny manner. So if you ask, what's the relation according the size of the particles? You can relate a table tennis ball to these gases, and in relation to this, you see some relations, like the Empire State Building with 1 micron having this size, or a day trip from Münster to Nuremberg, which is related to 1 millimeter. So with this in mind, you can imagine how wide the range of filtration must be. And that also enables or requires different medias. For instance, for water drops, we get mechanical separation or sieves, we get cellulose media, textile media, we get microglass media, also membrane media for small particles, and coming to the gases, which are very important also to protect the fuel cells, we're talking about adsorbents and membranes. And this I want to focus right now because it's about fuel cell, and this is more or less the only graph I show, I think. Here are some measurements we have done with SO2 exposure as a fuel cell. It was a small stack. And I don't want to go too far into detail, but what you see here is a decreasing of the cell voltage, which is caused by SO2 exposure. And what you see on the right is also a drift of a cell voltage by SO2 exposure. And what you see also is that with a filter we can recover the cell voltage on a certain way, but we know also that SO2 leading to covering at the catalyst. So it's very important to get rid of SO2. And this is done by adsorption. And the difference between adsorption and absorption, many of you know, is absorption is more a diffusion process, you eating it, and adsorption is more like a clown having a cake in the face. So adsorption is always stick molecules to the surface of something. So first information about coconuts. Coconuts has a very amorphous structure and are used to produce such activated carbons. There are different materials used to produce activated carbon, but coconuts have very good porosity and a very good baseline to construct this amorphous structure. And looking into the activated carbons, you see this porous structure. It's very interesting to see, looking in detail. And with SO2, filtering SO2 with such activated carbon works quite good. Well, honestly, it works not really good. It not really matches the requirements for the fuel cell, but it filters somehow. But there's ways to increase the performance. For instance, if you cover this porous media with potassium chloride and having this reaction, so you have an activating and an impregnation process of this activated carbon, you can even increase the performance of the filter. So you see here the breakthrough curve of a filter having the concentration on the raw gas side. And you see that you can increase the performance of the filter by certain impregnation process. I mean, many of you know maybe, but for some, maybe it's new information. But I today want to go one step ahead. We have not only activated carbon on the range of porous media, there are a lot of. And what I wanted to show is to go more in a crystalline structure, because crystallinity is the order of the structure. And the more order you have, the more precise you can adsorb something. It's very important to know. Activated carbons has from nature a very amorphous structure. And going, for instance, in such metal organic frameworks, very interesting to see. We get, well, honestly, I'm not a chemist, I'm an engineer. So for detailed question, ask my colleagues. But MOFs have this very regular structure and are good used to adsorb different media. Honestly, they are very expensive right now, so not really used in a wide range. But it's interesting to see. And what's even more interesting is if you have I would say a teaspoon with activated carbon, 1 gram, and you have a surface of about 1,000 square meters. Looking at metal organic frameworks, you have some that have even more than close to 10,000 square meters, but more than 5,000 square meters. And imagine that a football pitch has about, I don't know, 4,000 to 5,000 square meters. So it's impressive what materials can do and how porosity can be enabled. And yeah, this is something even inventors and specialists couldn't believe in the first place, that when this materials or these kinds of materials got invented years ago. So now, in the end, I have to step back to our portfolio and covering the wide range of different powers of the fuel cell. We have different solutions to adsorb media, to filter media, particles, and gases. And this goes from mobile applications, small power ranges, to even a big application for fuel cell. And therefore, we have also on our industrial sector that helps us to have centralized intake filtration. So, if you have any further question, just ask me. I'm looking forward to you. And for detailed question, just visit us at our exhibition.
Thanks a lot, Mathias Diekjakobs. It was a great presentation and haptical and partly delicious also. Thanks a lot.
Thank you very much.
We have to continue with the next presentation, but please visit him if you're interested, C78. Thanks a lot.